Hello everyone, my name is Ringo. I'm from the Aiming Engineering. Our team is working on monitoring of flexible barriers for slope safety against potential rockfall using IoT sensors. Before start, I would like to first express our gratitude to the HKIE Geotechnical Division and acknowledge Mannings Asia, Hong Kong RFID, and Dr. Zhou for their input to the use of IoT sensors for monitoring of flexible barriers. Our work is on monitoring of flexible barriers for slope safety against potential rockfall using IoT sensors. Just now, you see a flexible barrier in action. Now, let me give you a quick intro to flexible barriers. Flexible barriers is a defense measure adopted in Hong Kong against landslide debris or rockfall from natural hillside terrain. Flexible barrier typically consists of chain wire mesh, steel ring nets, steel wires in longitudinal and transverse directions, steel posts with bracing wires, and the base support. Its flexible nature of the barrier allows it to absorb the impact energy and reduce the velocity of the falling of debris. Current practice in Hong Kong under GED 5 requires routine maintenance inspection for flexible barriers, typically conducted by non-professional staffs, with maintenance work usually involve clearance of vegetation debris obstructing the flexible barrier. As flexible barrier is aimed to be, in some circumstances, the last line of defense to facilities against open hillside landslide hazard, we see the need in using IoT sensors to enhance monitoring of flexible barrier in an innovative ways. Our team has developed a tailor-made IoT sensor that can measure movement, transmit measured data wirelessly to a cloud platform, allow remote amendments of the sensor settings, and minimize power consumption so that the sensor can last for months before recharging. The IoT sensor is also small in size and easy to install through clamping onto the steel post without damaging the flexible barrier structure. From December 2022 to February 2023, our installed IoT sensor continuously measured the movement of flexible barrier posts, and the data was collected, pre-processed to ensure it was in a suitable format for further analysis. We engaged Dr. Zhou to utilize the 2-time series analysis to identify patterns and trends in the dataset, as well as analyze the relationship between multiple time series. We also employed the hidden semi-Markov model approach to determine the likelihood of abnormal movement for each post. By providing analysis to the measured data with assessment on the probability of its occurrence, we believe, in time, with more measured data, in particular during typhoon season, and make use of the observed pattern to build a benchmark data, this monitoring system can pick up abnormal movement to the flexible barrier effectively. To conclude this, the use of IoT sensor for monitoring the flexible barrier can provide a solution in an innovative and creative ways. Through a simple installation of IoT sensors onto the flexible barrier steel posts, we can enhance the monitoring of flexible barriers. Any large movement occurred can be measured and in time with the development of a benchmark data. The use of IoT sensor can become a valuable reference to geotechnical or civil engineers in monitoring the flexible barriers against potential rockfalls or landslides. Just like having a smart helmet to construction workers. That's all we would like to share today. Thank you for your time.